Hello and thanks for joining us for the first webinar on cryocoolers. Our topic today is advanced cooling solutions for hot air detectors. My name is Avishai and I would like to introduce my colleague Victor. Hello Victor, how are you?
Hello Avishai, how are you? Nice to see you all. Well, I'm very excited from this unique event and this special day.
What do you mean special day, Victor?
Today is the longest day of the year, turning from winter to summer and vice versa.
And how that's relevant for us?
Well, we can also see some turning in our market of the cryocoolers, working from the standard 77 Kelvin detectors to cryocoolers for hot temperatures.
That's very interesting, Victor. Okay, so let's start by a short introduction on Ricor. So Ricor facility is located in the north of Israel, in the middle of Israel Valley, one of the most beautiful places in our country. And before we start the review on the cryocoolers, we would like to present some key figures on Ricor. Ricor was founded in 1967. We have 220 employees that working in one site with a size of 7,400 square meters. We have two subsidiaries, Ricor USA that located in Salem, New Hampshire, and Netzer that located in the north of Israel in Carmiel. We have more than 53 years experience in the field of cryogenics. Our market share in the miniature cryocoolers is about 35%. Regarding volume, we delivered more than 170,000 cryocoolers, while about 35,000 in the last 3 years. Regarding space activity, so we are involved in space projects since 1994. And till today, we delivered more than 100 cryocoolers for different programs. And more specifically about our webinar, till today, we delivered more than 5,000 swap cryocoolers for hot detectors.
Okay, now let's talk about hot.
Well, Victor, what is hot that everybody is talking about? And where this all started?
Well, hot is high operating temperature. Okay, so the idea where the designers wanted to decrease the size of the system and understood that the cryocoolers take a big part of it. So they started to look for materials that will have the same performance of the infrared detector, but instead of operating at 77 Kelvin, they will operate at higher temperature, at 100, 110, 120, and above that. And by that, you can decrease the size of the complete system.
Okay, it's a real opportunity for existing cryocoolers to move from standard temperatures to hot temperatures and increase the reliability. And also for new cryocoolers to downscale swap parameters and to reduce size, weight, and power, and also cost.
Correct. And here how we started. So the first cooler that we've developed is the K562. Okay, it's an integral rotary cooler. Comes with a standard cold finger and a very short cold finger. That was the first cooler that was designed to operate at temperature of higher than 77 Kelvin. This one was designed to operate at 95 Kelvin. Later on, we've designed the K527, a single piston linear cooler split version, also arrived with a regular cold finger and a short one. Very efficient cooler. Later on through the years, we've designed the K562S, short improved. This one was developed in the years of 2012 and 2013, based on the K562S, but with an improved motor that could give much better efficiency to the system. This cooler can operate at temperatures of 150 Kelvin. And now, for our main event, this is the K580 and the K590, which will focus in our webinar today.
Okay, so let's review the specifications of both coolers models and start with the K580. So the K580 is a very light cryocoolers. It's 190 grams and highly compact in the size of the cold finger, 57.5 millimeters, the total length of the finger and the cooler housing. Highly low power, 1.5 watt DC power, which include the controller at 150K and 150 milliwatt. The MTTF is 16,000 operating hours at basic profile. The cooling capacity is 600 milliwatt at 150K at extreme conditions, 71 degrees C. And it's include the cold finger, common cold finger, and the cooler is qualified and under production since 2018. Let's now review the K590. So the K590 is a linear cooler, dual oppose compressor, and it's follow the objectives of the swap, which means that it's a very light cooler. It's 180 grams and highly compact. The compressor length is 52 millimeter with a diameter of 26 millimeter, and the highly compact cold head, which is a total length of 40 millimeters, which include the finger and the warm end. From power efficiency, so the power consumption is 1.8 AC power at 150K and 180 milliwatts. Regarding reliability, that it's an important parameter, so it's a target for long reliability for more than 30,000 operating hours. From cooling power, so it's about half watt cooling power at 150K at 71 degrees C, and also 370 milliwatts at 120K in the same conditions. The cooler is qualified and under production since 2020. So we have two coolers, one rotary and one linear. And the question is, which one is better?
Well, Avishai, this is a very, very interesting question, and the answer depends on the application. We have two cooler models. Both of them are very small in size. This is the K580. Look how small it is, compact, lightweight, only 180 grams. And on the other hand, we have the K590. Although it's a split and a bit bigger, still very compact and small in size. So they're looking a bit different, but they're both could fit to many, many different types of applications, and it's very difficult to answer which one of them is better, okay? In terms of cooling capacity, the K590 can hold about half a watt at 150 Kelvin, while the K580 can hold about 600 milliwatt. So it is a bit better right now on the K580, but we work to improve the version of the K590 so we can hold at least the same cooling capacity like the K580, which means that we will be able to hold better, bigger detectors that consume more heat, or on the other hand, operate with detectors that need lower temperatures, such as 120 Kelvin or 130 Kelvin. Last thing for this comparison is the efficiency. So, as probably you know, the rotary are always much more efficient. And this cooler, the K580, draws only 1.5 watt at 150 Kelvin at room ambient. This is very, very low input power. The K590 draws 1.8 watt at 150 Kelvin, but still, this is very, very efficient. So they're both very efficient, Now, it really depends if you're looking for those fractions of a watt in your application. But both of them could be very, very good to your needs, especially when it is a handheld application, as we can see in the graphs of the performance.
Okay, let's now review more key parameters like acoustic noise, induced forces, and MTTF.
Probably the most important parameters of those coolers. And yes, the rotary and the linear differ. If you're looking for the most silent cooler, you will probably ask for the linear. Okay, the linear can hold up to 10 meters of non-detectability, while the rotary, the K580, will hold at the area of 20 meters undetectability. But in some of the applications, this is not the most important parameter. So really depends if you're looking for a completely silent and undetectable system, or if it's something on an urban application or other types that the acoustic noise is not so important. In terms of the induced forces, well, here we have a very big difference between these two models. The split linear, as you all aware, is balanced on the compressor, and the induced forces are probably neglectable, at least at the area of the operating frequency and above that. On the other hand, the cold side, on the cold head, you have induced forces. Sometimes they could make some interference, but the fact that the cooler operates on a single frequency makes it easier to attenuate it. On the other hand, the rotary is almost completely balanced. So there are induced forces, but at a very, very low level. How much very low? It depends. It depends on the operating frequency, which is an output of the load, the cold tip temperature, and the ambient. The K580 will draw about several grams at the standard operating frequency of 30 or 40 hertz. Right now, just to let you know that we work on the improved model of the K580, and we plan that on the spec level, it will be lower than 10 grams at the operating frequency of 80 hertz. So it means that almost all of the applications will see very, very low level of induced forces. So still, probably the linear is a better solution, but the K580, the integral rotary, could give you very good results also in terms of the induced forces. Last parameter for now is the reliability. And as always, we know the linear has no bearings, so the reliability or the potential reliability of the cooler is better on the linear. The K590 probably will work 20, 30, 40,000 hours on most of the applications, which is very good if you have a system that operates 7/24. But if not, if it's a system that only operates several hours a day, even the K580 that could give you 16,000 hours on the basic profile, it's a very good solution. So it can still be integrated into a camera that will work for several years if it's not on a 7/24 operating basis.
Okay, let's now expand the discussion on more parameters like interfaces, cold fingers, and controllers.
Okay, again, it's a very, very good question and very important discussion, because when you deal with the integral rotary and the split linear, they differ. Okay, so the integral rotary, it's a cooler that is very easy to interface with. You just throw it into the system and it operates. Very simple mounting on the mounting surface. No special things that you need to do. On the other hand, the size is what you have right now. There's nothing to do about that. On the other hand, the split linear gives you some more flexibility because of the split configuration and the fact that you can orient the cold finger and the compressor based on the exact application that you have. So it's easier to design it and you can get more flexibility. On the other hand, you should take into account that the linear version is something that is a cooler that you need to take care about the heat dissipation from it. So you need to dissipate the heat from the compressor and from the cold head, which means that this cooler is much more sensitive than the integral rotary one. So again, they differ, and each one of them has an advantage and a disadvantage. In terms of the cold finger, so the K580 works with the common cold finger. It's a cold finger that some other cooler manufacturers hold, means that you can use the same cold finger, the same dual design with this cooler and some other coolers that are available on the market, and this is a very, very big advantage. The K590 uses a unique cold finger, and as you mentioned earlier, it's only 40 millimeters in the length of the cold head, and the cold finger is even shorter. So here you gain a very big advantage in terms of the length. So the fact that you have a special cold finger gives you the advantage in here. And the last thing are the controllers. The K580 controller is designed to work inside a special case that, you know, it's very easy to mount and you can interface it with all your electrical connections. So the controller is inside, is protected, very easy to implement. On the other hand, it will be a bit bigger if you compare it to the controller of the K590. Look how small it is, okay? This controller right now is being delivered as a standalone version. If some customer would like to have it inside the box, we can design the box, but at the moment it goes like that. And if some customer would like to implement the controller inside his system, it is also acceptable, no problem with that. So again, very small packages, okay, probably the smallest that you can see today in the market. And again, you can use it inside the box or you can use it just on the PCB level and embed it into your system.
Okay, Victor, that's a comprehensive review. Let's now review production aspects. And Victor, what about the price of these both models?
Well, Vish, I just prepared a proposal for you. I will hand it to you by the end of this presentation. But agree, let's talk about the maturity level of those models. So as we discussed earlier, both of those coolers are under production. The K580 is under production since 2018, and we've delivered more than 1,000 units till then. As you can see in the pictures, we have a lot of coolers under production and under tests, so it's a very mature cooler model. Of course, not like other cooler models that we have since the early 90s, but still very mature, and I think that it's ready to be integrated into many different type of applications. The K590 is a bit younger. It's under production since 2020. And up to date, we've delivered more than 300 coolers. So it's in a good maturity level, but still a bit younger than the K580. But don't be afraid. We're working on a daily basis to improve that model, and it will be ready for mass production in a very, very short term. And in terms of price, that's a difficult question. We are both very cost effective in these cooler models. It is known that the linear coolers are a bit more expensive compared to the rotary, but it really depends on the life cycle cost of the complete program. So it's not only the cost of the product, it's the cost of the complete life cycle, and each system should make her own calculation and try to understand what will be the best product to invest into. Okay, so what we've learned so far?
Let's make some short summary, Victor. So the hot detectors provide us opportunity to downscale parameters. As we can saw in both models, the K580 and the K590, the swapped objectives followed, and the size reduced, the weight and the power. Both units are efficient. Other parameters like acoustic noise and induced forces took into consideration. Both are silent and with low induced forces, while the K580 will have the next step of improvement with lower induced forces. Both target for high reliability, and we reviewed also the cold fingers and the controllers, the digital controllers for both of them, and production aspects. And yeah, that's it. I think we cover it.
Okay, so sounds very, very interesting. Very interesting, and it looks like there is a very good solution for many, many different types of applications.
Now, Victor, let's see what next.
Okay, so we have several directions when we look forward. First, dealing with those models, we need to optimize the performance to a very wide range of temperatures, because we see that it's not only 150 Kelvin. So from one hand, we are going to optimize them to operate in a very good and efficient way to the temperatures of 120 Kelvin. On the other hand, we start to see some applications that are looking for higher operating temperatures, such as 180 Kelvin. So we still need to make that optimization in order for those coolers to operate at those conditions. This is one direction. The other direction is making some improvements on those models. So this year we're going to finish the K580i, K580 improved model, as you mentioned earlier, improving the induced forces, improving the digital controller, and making that cooler highly affordable. The K590 is going to make a big improvement in terms of the compressor and the robustness of the compressor, and we are going to optimize the performance, and hopefully we will gain more cooling capacity, so those both coolers will have much more than 500 milliwatts at 150 Kelvin. Besides that, when we look to the future, we will try to find new cooler models with new technologies, maybe to be more efficient or to be smaller in the size, or having a lower weight.
Okay, so we would like to thank you for joining the first webinar, and thank you, Victor, for this webinar.
Thank you, Avishai. Thank you all for joining us, and we look forward to see you in the near future. You are all welcome to visit us in our lovely facility, and of course we will hope to have frontal meeting with all of the customers. And right now we would like to open a session of questions, and you are all invited to use our chat and write down all your questions. We will be here to answer all the data that you are looking for. Thank you. Hello again. Hello to you all. For those of you that it's a good morning, for those which is a good afternoon or good evening. Hello, Avishai.
Hello, Victor.
Nice to see you again.
Yes.
We would like to open our session of questions and answers. You are all welcome to use the chat for questions. We will look for that. Well, I see that we have a question already.
Okay, so the first question is, what is the lowest stable temperature achievable?
Okay, so thank you for this question. We haven't mapped all the operating temperatures, but for both the K580 and the K590, we already operated at 120 Kelvin. We have some requests to test it at 110. It all depends on the load and we need to see if we have enough cooling capacity for that certain temperature, and also what is the maximum ambient that should be used. So basically it's a kind of combination between the ambient, the load, and the cold tip temperature, but the cooler can operate without any problem at 120 and also for 110 Kelvin.
Okay.
Okay.
Question, why you designed a K590 to be a dual opposed and not a single piston?
Avishai, that's a question for a completely new webinar. Okay, so yes, you're correct. The K590 is a dual opposed, but we also have the K527, which is a single piston. And when we approach the new design, we understood that we need to look for a more generic solution because the single piston is very good and could be very compact, but it's difficult to be a generic product. So the dual opposed configuration, which is completely balanced because of the two pistons, it's easier to implement, easier to install it in the system. So we've designed to use the dual opposed. Again, the single piston is a good solution. Sometimes people may claim that it could be more affordable. Yes, there are less parts, and it could be, on the BOM level, it could be maybe a bit more affordable, but not such a big difference in the complete cooler level. So we've decided to go for the dual piston approach. Okay, let's see what other questions we have here. Okay. Okay, so is it possible to design the K590 with the common cold finger?
Yes, so basically the K590 is a dual opposed compressor and include a compact controller. And then we can use the same components, the compressor, the dual opposed compressor, and the controller, and adapt the cold head, as mentioned before, that it's 40 millimeters, and replace it, the internal parts, in order to fit with the common cold finger. So this model is named as the K588. We didn't mention it today, but we already manufactured such a cooler and have some test results. And basically we can proceed with such kind of a derivative upon a specific request.
Okay.
Okay, does Ricor do any manufacturing in the USA? And if not, is there any plans to bring manufacturing to the US?
Thank you for that question. So at the moment, the manufacturing is done here in our facility in Israel. But when there will be a certain program with a certain request, definitely something that we can think of and work with the customer and do some work in the US. Once we have that opportunity, definitely something that we'll think about. Okay, let's see. Oh, Avishai, this is a question for you. Hey Avishai, can the K580 replace the K508?
Can the K580 replace the K508? So K580 is basically from a different family of products, since it's what we call for the swap projects, for swap products, while the K508 is for the non-swap. So for the K508, we have a different line of products that can be the next steps, mainly in the reliability aspect. So the next step is the K508N, that almost double the reliability of the K508, and this is available and qualified, and could be replaced existing K508. While the next step is to introduce the K508C, which will be the next step, another step in the improvement in the reliability. So this is what we call the non-swap, and those products also comply with standard detectors and also with hot detectors. While the K580 is defined as a swap cooler, and then it's more for different family and specifically for the hot. So to summarize, the K508 family is applicable for hot and non-hot. So then we mentioned that it's a non-swap, but applicable for both types of the detectors, while the K580 and 90 and 88 are applicable for hot detectors, which typically work on at 150K or in this range of temperatures.
Okay.
What is the best performing cooler at something
Colder
than 150K? Let's say 120K.
That really depends, because as we mentioned, both of the coolers, the K580 and the K590, can operate at 120. Of course, if you could operate at a higher temperature, you will get a better efficiency, better reliability, and also some other parameters. But once you operate at 120, now the question is the load. So assuming that you have the same heat load, the efficiency of the K580 will be a bit better compared to the K590. So if the question in terms of better is efficiency, then you will have a better power consumption on the K580. However, if the question is reliability, then the K590 will have better reliability compared to the K580. So in order to answer which one is better, we need to understand exactly what the customer is looking for in terms of the cooler parameters. Okay, we have a question here. What is the diameter of the cold finger?
Okay, so the diameters is basically a kind of an optimization that's done between different parameters like rigidity, heat load and length, and of course wall thickness. And basically it's optimized due to also to the swap objectives. So it's a lower diameter than we used to have in other cooler models. In this case, is a 6 millimeter diameter. While, as we mentioned, there is a different length between the K590, that is more specifically for this model, and the common cold finger, which is fit for the K580 and 88. So both of them are 6 millimeter with different lengths and different interfaces, and this is mainly the main differences. The total length of the cold head is a bit different in both models.
Okay.
Okay. Does the K580 operate on the same frequencies like the K508?
Well, this is a very interesting question, and the answer is no. We've designed the K580 to operate at higher frequencies because we understood that when you operate at higher frequency, you are less interfering the camera because of the bandwidth of the camera. So it's better to operate at a higher frequency. The problem, of course, with rotary coolers that the induced forces are dependent on the operating frequency. So what we've done, mainly in the improved model, is to reduce the level of induced vibration to a very, very low point where it's less than the level of vibration of the K508 operating at lower frequencies. And right now we can say that the improved model is going to be less than 10 grams on 80 hertz operating frequency, and the 80 hertz will cover a very wide range of operations. Okay, let's look for some other questions here. Okay, this is an interesting one. Can I use the K580 with my camera's controller instead of cooler's controller?
So yes, basically there are two options in order to use the controllers. The first is the standalone controller. So we saw that there is a compact controller for the linear and also for the rotary. These are standalone controllers that could be used separately for the cooler. Another alternative is in order to save mainly volume and to simplify all the concept, is to integrate the detector, the controller, to be part of the electronic board in the camera. So yes, both alternatives are available, or to use a standalone controller for each model, or to integrate it as part of the electronic board.
Okay, thank you.
Okay.
We can take that one on the left. On the right, sorry. This
okay. Please clarify the amount of heat load that is rejected on the hot side of the rotary cooler, as it seems to be much less than the
linear.
Linear,
Exactly,
okay,
linear.
maybe some spell.
Yeah, okay. So the heat that is rejected from the cooler is basically the input power of the cooler, just without the controller, what we call the AC power. So if the cooler draws 1.5 watt at 150 Kelvin, 150 milliwatts, then the cooler and the controller draws that amount of power. So about 80% of it goes to the cooler. So roughly it's 1.2 watt that are dissipated from the hot side of the cooler. So in general, it could be 80%. You know, you can take into account maybe higher efficiencies of the controller at higher loads, but it's roughly more or less that amount. And yes, we've discussed that the efficiency of the rotary cooler is probably a bit better than the linear one, and it will draw less power. However, you should take into account that it's always preferred to draw the power from the mounting surface and also from the motor. Again, it depends on the way that you integrate it into the camera. But yes, it's always preferred to reject the heat from all the surface. So that would be the answer for that. Okay, let's see some other questions that we have. Okay, what is the K588 length of the cold head?
Okay, so as we mentioned before, we have the same compressor, the dual opposed compressor, that's applicable for the K590 and also for the K588. While regarding the cold head, we mentioned about a specific cold finger for the K590, and the total length is basically the cold finger and the warm end. So for the K590 is 40 millimeters total length. Regarding the K588, since we are using common cold finger, as mentioned before, the length is a bit different, and also the warm end is a bit different. So the total length in this case for the K588 by using the common cold finger is 47 millimeters. So the difference between both models is about 7 millimeters.
Okay.
Okay. Okay, a question. What is the maximum recommended length of the transfer line on the K590? Is there a recommended limit on the transfer line bending?
Okay, so like all split coolers, the K590 is the same. The shorter, the better. So if you can design the split configuration with the shorter transfer line, and by the way, this is the transfer line for those of you who are not familiar with. So the shorter, always the better, because you lose a little bit efficiency when the transfer line is longer. We have a document that we can share with our customers that will give you all the recommendation also regarding the bending radius of the transfer line. So everything is very clear. We will just come back to the customer with that document, and he will design the transfer line by its own. But again, it is recommended that it will be the shorter as possible. Okay, let's see some more questions. Oh, that's a very good one. Can these coolers be used in space environment?
Okay, so yes, in principle, yes. Basically, and as we mentioned at the beginning, Ricor has have experience in the space since 1994 in different types of programs, space programs. Until today, as mentioned, we delivered more than 100 coolers for space programs. Mainly, those models are K508 and now more K508N. While those coolers, the hot coolers, could be also an option, of course, for the next step. So we need to adapt some special process during manufacturing, special screening in order to have enough volume and to screen those coolers that fit from performances, reliability, and repeatability, and all what is space is defined. Those are not space qualified, they are space heritage. While we had a lot of experience with our, as mentioned, K508 and K508N, and the next step could be also for new coolers to start use also on the same principle.
Good.
Okay, question, are these coolers qualified for airborne and maritime applications?
Well, that's interesting. In general, we do not qualify a cooler for an application. We qualify the coolers with the requirements, and we have a qualification program. And for us, it doesn't matter if it's airborne application or maritime application or land. Basically, all the coolers are being built, designed in a way that are completely generic. They are integrated with the infrared detector and can be used. The same cooler with the same detector can be used for many different types of applications. So, are they qualified for airborne? No, there's no special qualification for airborne. But are they used in airborne application? Yes. All of these coolers, by the way, also the K580 and the K590 are already integrated in airborne application. So it's not a problem at all for those coolers to operate at these conditions. Okay, so I see that we are very close to our time limit. Let's see. Well, we are sorry that we cannot answer all the questions, so let's take another one. Are there any special requirements for heat rejection for these coolers?
Yes, so basically we have a document that summarizes all the methods of heat rejection, which means that it's defined the mounting surfaces and what are the heat sources and what is the expected power that you need to dissipate for each model and what is the method how to dissipate it. So yes, we have for both of them, for the K580 and 90, and we can share those documents per any specific request.
Thank you, Avishai. Unfortunately, we are on our time limit, so we will be more than happy to answer more of your questions. We will write down all those questions and we'll come back to you later after this webinar. So let's call it a day.
Thank you, Victor.
Thank you, Avishai. I would like to thank you all the participants. I would like to thank our team. Agar was running this day. And hope to see you first in our facility and in-person meetings. And hope to see you soon.
Thank you. Bye-bye.
Bye-bye.